Now let's talk about domain of compositions of trig functions. Now, when we look at the domain of a function of its inverse, normally we would just think of it being like all real, something like that. But here's the problem with inverse, is that sine inverse, the domain is limited from -1 to 1 because the sine values can't ever be greater than that. So here's what it's saying. If x is in between these two values, then these two would just cancel and you're left with x. But here's the problem. If it's outside those values, it's not real. So for it to exist, it's got to be between -1 and 1 for sine and cosine. Tangent can be basically all reals. That would work for tangent. Not basically, it could. But when we look from the inverse perspective, things are a little different. X has to be between -pi/2 and 2, and here's why. Let me just draw it. When we deal with the function in the original is for sine, you think about the first positive value, the first negative value. So where this wouldn't blow up, where you would still have a function for sine. The positives are here. Here's the closest positive sign on this quadrant. The closest negative is not there because sine is still positive, and it's not there. The closest negative is actually down here, which is negative. That's negative sign there. Whoops. In the negative of the first quadrant, which would go from pi/2, and go in this direction. This would be -pi/2. That's why for sine it's this, but for cosine it's different, because for cosine, this is cosine's positive. The first negative, the cosine's also positive here. The first negative is technically over there. I know these are the same distance going here and going there, but if it's the same, you take the positive. So this would be from 0 to pi. That's why it's those values. And for tangent, all students take calculus. Tangent, the first two are these two. So again, it's like sines from those values. So that's just going over domain, and that's how you do that. So let's take a look here. Now, again, the values, if you have a normal function outside the inverse, these have to be between -1 and 1. It is, so we can have a good answer. So these should cancel out because they're the opposite. Arc sine, remember, is the same thing as sine inverse. And so those should cancel out, and the answer is 1/2. Just because some people need practice with the hand trick, I'll walk you through how you do this piece by piece. You would first say, what is the sine inverse of 1/2? Well, 1/2 is the same thing as square root of 1. So you look at if it's inverse, you look at the back of your hand. I'm going to go one finger and then bend. I should be bending right now. If you're looking at the back of your hand, bending your ring finger. You come back and you say, what angle is that? Well, that's the pi/6. That's my pi/6 finger, so that equals pi/6. Then you would come back to the outside and say, what is the sine, now that we know this is pi/6, of pi/6? And the answer, well, you still have that same finger bent. You flip it back over, and you get the square root of 1/2, because you have one finger up top, and your h is always 2, which is the same thing as 1/2, like I was saying. So those cancel because it's within the domain. Here, these two also cancel. The question is this within the domain? Remember, cosine exists in the first quadrant. That's positive and negative. So the first one that's positive is here. This is also positive, so it's not going from there. This is the first one where it's negative. It's over there. So it exists anywhere between these two values. So from 0 to pi. But look up here. We have cosine of 5pi/2. That's going to be a problem. So the answer is not going to be 5pi/2. I know some people would think that, but 5pi/2 is wrong, because it's not the simplified version. Let's think about this. 5pi/2, that's the same thing as 2.5 pi. If I wanted to simplify that, it's coterminal with 0.5 pi, or 1/2 pi, which we normally would write as pi/2. The pi/2 is actually going to be our answer here, and let me show you why. It's 5pi/2. So this is pi/2 here. This is pi. This is 3 pi over 2. This is 2 pi, which is the same thing as 4 pi over 2, which means this is 5 pi over 2 when I go all the way around. So I go like this, and I end up here. That is 5 pi over 2. Okay, so in terms of if you wanted to use your fingers, a hand trick, this is normal cosine. So you look at your hand trick, this is like a pi over 2. So you take the value, which is your thumb, you take it and you bend it. In cosine, I have 0 fingers. So it's 0 over 2, which is simply 0. So this value, cosine of 5 pi over 2 equals 0. Now why I say it was a problem earlier, was what I meant is our answer is not going to be 5 pi over 2, because now that I know that's 0, I'd say what is cos inverse of 0? That would mean, look at the back of my hand, I want 0 fingers, so cos is x, which starts from the bottom. I'd have to run my thumb. You flip your hand back over and say, what value is that? My thumb? Well, the answer is, it is pi over 2. And so that's why the answer here is pi over 2. The way of thinking about it is a coterminal. There was a shorter coterminal. We look for an answer within here, and the first one that's coterminal was pi over 2. So that would be the best answer. So here, let's think about this. This is negative 2.5 pi. Is that within the normal answer? No. So I can't just go cancel, cancel. So I'm going to simplify it. What is negative 5 pi over 2 coterminal with? We'll take away 2 pi. Not take away, it's negative. I need to add 2 pi. And 2 pi, if I want a common denominator, 2 pi is equal to something over 2. What is that something over 2? Well, multiply by both sides, and we'd say that x equals 4 pi. So 2 pi is the same thing as 4 pi over 2. I'm going to change this to 4 pi over 2. When I add that, I get negative pi over 2. Is that within the workable domain for tangent? Well, let me think about this. Tangent, if I did that, all students take calculus, tangent's positive there, it's negative here, and it's negative here. Which comes first? That's obviously the quickest way to get a tangent that's positive. But if I wanted a tangent that's negative, what's the quickest? Is it getting to here or there? Well, it'd be there. So these two are eliminated. I'm looking for values that are somewhere in here. Negative pi over 2 is, so that's going to actually end up being my answer here. So typically when you see an inverse tangent and a tangent, you just think, oh, those cancel each other. They're opposites. But you have to be careful. You have to be working within the reasonable domain, meaning you find something, you find the value, the coterminal angle that is the quickest that you could reach starting from the x-axis. Here's one for you to try.